Okay, so the first question will be a pretty simple one. It is the area of a pool of water that is forming under a leaking pipe is given by the function A equals 4t plus t squared, right? That A stands for the centimeters in water. That means the amount of the area of the pool that is being created under the leaking pipe. And T will be the amount of seconds, the time it passes, the seconds it passes, right? So in case you are kind of lost by the example, the idea is pretty simple. Somebody is running water through a pipe, but the pipe is leaking that water, right? So as the time passes, that those drops of water that are coming into the ground are creating a little pool of water. And as the time increases, you would expect that the water, the pool of water is gonna go bigger and bigger and bigger because more and more water is being dropped into it, right? The pipe is leaking more and more water. So if you were to put that into mathematics, you would expect for the rate of change to be positive because again, as the time passes, the area would increase because that's what you would expect, right? The amount of water coming into the pool is bigger and bigger. So you would expect that the rate of change is positive. Let's see if that is what it is in this example in mathematics. All right, let's see. So in question A, the first part says, what is the area of the pool initially? All right. The area of the pool initially means when time is 0 seconds. So we're going to do this change in the first example, in the first equation. So the amount of area, right, will be 4 times 0 plus 0 square, right? What I just did was I changed the value of t by 0. And again, why t equals 0? Because the question says initially. Initially, we're going to assume 0 seconds has passed. 0 seconds have passed. So t equals 0, we just replace, right? This is 0 and this is also 0. So the amount of water, the area of water will be 0 centimeters square. There are no water. There is no water in that pool. The pool is completely dry. Let's go with question B. What is the area of the pool when t equals 5? The exactly same exercise. So now 5 seconds have passed, right? So we know 4 times 5 again. 5 seconds have passed. So I'm going to replace t for 5. This will be 4 times 5 plus 5 squared. And this will give me 20 plus 25, right? 5 squared is 25 plus 20. This is 45 centimeters square. Don't forget about the units. Don't forget about the units because this is an exercise with some context behind it. So you need to put the units, right? So at exactly 5 seconds, the pool that is right under the leaking pipe has an area of 45 centimeters square. Now, what is the amount of water, the volume of water? We don't know that one because this function is showing us the area, not the volume. So we don't really know about the amount of water in the pool, but we know about the area, right? And this is 45 centimeters square. All right, let's go for question C. Let's put it right over there. All right, in question C, they're asking us to find, to interpret dA over dt. So what is this? What is dV over dt, right? Mathematically speaking, we all know this is the derivative of the function, right? You need to derivate a equals 4t plus t squared to find dV over dt, to find the derivative. But what is the meaning of this? What is this representing in this example, in this exercise? All right, that's pretty simple. Every derivative represents a change of one variable when another change of another variable is happening. In other words, this thing, dV over dt, represents the change of volume. I'm sorry, it's not B. I was reading the first question, sorry. dA over dt. Beautiful. So this represents the change of area as the time passes by, right? This is the amount of water that is dropping from the pipe as time goes on. That is what this represents. The amount of change in one variable, in this case A, so the area, as the other variable changes, as in this case, the seconds. So again, this represents the amount of area as the time goes by. That is what that represents. All right, let's continue with question D, sorry. All right, D. Find the value of the A over dt when t equals 5. Find the A over dt, right? The A over dt, so the derivative of this, but when the time equals 5. This is absolutely simple. The A over dt will be the derivative of this function. This is exactly 4. You just need to derivate the first one. 4, the derivative of 4t will be just 4, right? Plus the derivative of t squared, which is 2 times t, right? Now, we have the derivative, but we didn't replace by t equals 5, which is the question, right? In question C. In question D says, find the value of the A over dt when t equals 5. To do that, just replace the t by 5. So evaluating will be 4 plus 2 times 5, which is exactly 10 plus 4, so 14 centimeters square over seconds. Now, take a close look at the units here. Look, since this is a change of 1 unit over the other unit, what I'm expecting is that the units is also a change in units. And what I'm saying here is that at exactly 5 seconds, the amount of water, the amount of area is increasing by 14. That is what I'm saying right there. Right? Because the unit says it is centimeters square per second. So every second there are 14 centimeters square more. That is what it's saying right there. All right, let's continue. And question E. A, B, C, D, E. Use your answer to B and D to explain what is happening to the area of the pool. To B, this answer, we're going to use this answer, and we're going to use this answer to explain what is happening to the area of the pool. All right, pretty simple. What is happening to the area of the pool is that at exactly 5 seconds, the amount of water, the amount of area in the pool is increasing by 14 every second, right? We know that. At exactly 5 seconds, the amount of water is increasing by 14. But the amount of water present in the pool is exactly 45. Remember, this is a change, so this is an increase of water, and this one is not a change. This is the amount, the exact amount of water present in the pool. So what's going on right there? What's going on in exactly 5 seconds? All right, the water is increasing. It is increasing from something which we don't know how much it was to exactly 45 in the 5th second, right? So we could assume this. We could assume that exactly 4 seconds ago, there were 45 minus the 14 that increased in the 5th second. So you could assume that at exactly 4 seconds, the amount of water would be 31, right? 31 centimeters square. The amount of area, sorry, will be 31 centimeters square. Because at the 5th second, you just got an increase of 14 centimeters square. That would give us the 45 that we have over here. Did you get it, guys? All right, hopefully this was useful. If you have any more questions, just let me know, all right? I'm going to stop the recording right now.